Okay, so let's take a look at practice quiz 4 number 2. So the question says for the men's scatter plot, find the line through 4660 and 2240, then find the RSE for the line. The RSE stands for the residual standard error. So here's the scatter plot for the men. Here was our points. So the 46 represents the age, and the 60 is the friends, 22 is the age, 40 is the friends, and so forth. So we plot these over here. We did this in question 1, practice quiz 4. So note that the points on the scatter plot, so these 3 points here, do not all lie on the same line. The line that best fits the points in a scatter plot is called the regression line. You might say, well, what do you mean by best fits? Well, it would mean, just eyeballing it would mean maybe a line like that or something would be the regression line. So it may not go through any of the points, but it best fits the data. We're going to give a more precise definition of what that means later. Okay, so let's first find the line through 4660 and 2240. Okay, we're going to find it algebraically. So the line it's talking about it would be going through the 4660s at this point and the 2240. So let me take this away and let me graph this line in here. So just draw a line through these 2 points. Let me do it. So doing that, we get then. Okay, so I've drawn it in here. So that's the line through 4660, 2240. Okay, so let's find this line algebraically. So there's a way to do that. So given 2 points, there's a way to find the line algebraically. So let me write that up here. So I'm going to erase a few things and we'll keep going. So here's the way to find the line algebraically. So given 2 points, x1, y1, and x2, y2, we use the equation y minus y1 equals mx minus x1, where m equals y2 minus y1 over x2 minus x1. And here's our 2 points in our case here. So we're going to label, say this one x1, y1, this one x2, y2. Let me do that. Okay, so I have my points here. So I'm going to call the first point x1, y1. So the 46 would be the x1, the 60 would be the y1, the 22 would be the x2, the 40 would be the y2. So let's plug in up here. So it says y2, my y2 is 40, minus y1, y1 here is 60, all over x2, which is 22, minus x1. So simplifying that, on top we have 40 minus 60 would be minus 20. And on the bottom we have 22 minus 46, which would be negative 24. And we can simplify this fraction a bit. So notice here we can write these numbers as the following. Okay, so we can write negative 20 as negative 4 times 5, and negative 24 as negative 4 times 6. And cross off the negative 4s here. We're going to get 5 over 6 for our m, our slope. M's called the slope. So our slope would be 5 over 6 here. So our m is 5 over 6. So now we're going to plug into this guy up here, which is called the point slope. So let's plug into that. So plugging into that here. So it'd be y minus y1. y1 is 60. Equals then m, which is 5 over 6, times x minus x1, which is 46. Okay, so next then we will multiply both sides by 6 to get rid of the fraction down here. So let's multiply both sides by, let's get rid of the 6 right here. So let's multiply both sides by 6. So doing that we get then, so multiplying both sides by 6, you'd have 6 times y, 6 times negative 60, 6 times 5 over 6 here. The 6's will cancel here. Then I can multiply this 5 in and multiply the 6 times 60. So multiplying the 5 in, we'll have 5x and 5 times 46. Let me do that here. So doing that, we get then 6y, then 6 times 60 is 360. 5 times x, 5x. 5 times 46, you can check in your calculator. You go 5 times 46, it's 230. So I want to solve for y now. So let's add 360 to both sides. So doing that, we get then, so adding 360 to both sides here. Then negative 230 plus 360 is 130. So it'll be 6y equals 5x plus 30. And now let's divide both sides by 6. So doing that, actually just write it as one fraction here. And this guy, go like this. So doing that, we get then, okay, so we get then y equals 5x plus 130 over 6. So that's the equation of this line up here that we're trying to find. So y equals 5x plus 130 over 6. Okay, so we've done the first part of question 2. The next part tells us to find the RSE. So that's the residual standard error. So let me talk about what the definition of this. Okay, so before talking about the RSE, let's talk about a residual. So residual is the difference between the scatterplot y value and the predicted y value from a line. So let's just, in our case here, the line we just found here was y equals 5x plus 130 over 5. If you go back over here, and their scatter plot values were these guys. So up here you can see our scatter plot. These are the points we used to make our scatter plot over here. And the y equals 5x plus 130 over 6 was our line. Okay, we're going to be using the line to find the predicted y values. Okay, let's go back over here. Okay, so I just noticed it should be divided by 6 right here. Okay, so this is our line, 5x plus 130 over 6. So let's find the predicted y values for our line. So we'll be using the x values here, so our ages. So 46, we'll be using 22 and 18. So when x is 46, so you're going to put 46 in place of x right here. So I've done that here. So it'd be 5 times x, but x now is 46, plus 130 divided by 6. And you can check if you put out in your calculator 5 times 46 plus 130, it's 360. And you divide that by 6, it's 60. So you can see the predicted y value is 60. And actually the scatterplot y value is also 60. This is a scatterplot y value right here. Okay, let's do the 22 next. So doing 22 next. Okay, so we're using the 22 next because that's the next age right here, 22. So I'm going to plug the 22 into our y equals 5x plus 130 over 6. So doing that, so putting 22 here in place of x, you'll have 5 times 22 plus 130 over 6. And you can check 5 times 22, it's 110, plus 130 is 240, divided by 6 is 40. And that corresponds with the scatterplot y value here. That's 40 also. And you might say, well, are they all going to be the same? Not necessarily. You can see the way the line was defined, actually, how we create this line was the line going through these 2 points. So of course, those 2 points will be on the line, so that's why they're perfect agreements here. But let's do 18 next. 18, the predicted value of pi is not going to be 25. Let's check it here. Okay, so now let's do the predicted value when x is 18. So we're going to put 18 in place of x up here. So it'll be 5 times 18 plus 130 over 6, which is 220 over 6, which is approximately equal to 36.66. Okay, so you can see that doesn't agree with the 25 up here. That's the scatterplot y value. So now again, the residuals up here is defined to be the difference between the scatterplot y value and predicted y value. So let's compute the residuals now. Let me do it right here. So doing that, we get then Okay, let's do the residuals here. So again, residuals is the scatter plot y minus predicted y from line. So we're going up here. So for 46, the first point here, the scatter plot y is 60, so it's going to be 60 for our first one. And our predicted y value when x is 46 was also 60, so it's going to be 60 minus 60. So it'll be 0 for this one. Then next one, the scatter plot y for 22 is 40, so 40 is the scatter plot y. So 40. And our predicted y when x is 22 is also 40 right here. That's when x is 22. So it's going to be also 0, this residual. And our last one, our scatter plot y value for 18 is 25. So 25 is the scatter plot y value for 18. So 25 minus, and our predicted y value from our line when x is 18 is 36.66. That goes here. 36.66. So doing that subtraction, we get then, gives us then negative 11.66. Okay, so now I think we're ready to compute the RSE. So let's do that next. Okay, so here's how the RSE, or the residual standard error, is defined. It's defined to be the square root of the sum of the squares of the residuals divided by n minus 2, where n is the number of scatterplot points. So it looks kind of intimidating, this formula, but pretty much you're going to square each of these guys here to be 0 squared plus 0 squared minus 11.66 squared. And n in our case, well, here's our scatter plot we made from these. So we have 3 points here. So in our case, n is 3. So we write that here. So in our case, n is 3 because we have 1, 2, 3 points. Okay, so now let's compute the RSE for our case here. So doing that, we get then, so in our case, plugging into the formula, so we're going to take our first residual, actually we'll take the negative 11.66 guy, I have it squared here, then takes the next residual 0, so it'll be 0 squared, next residual 0 squared, divided by n. In our case, we said n is 3, subtract 2, square root of this whole thing. So that will be our RSE. So you can check if you work this out, it just becomes 11.66. Okay, so the RSE, the 11.66, kind of tells us how good our line fits the data. So let's go back to our line over here. So this is our line up here. You can see it went through 2 of the points, but didn't go through this one. So the RSE is giving us a measure of how good this fit is. So pretty much the bigger the RSE value is, the worse the line fits the data, and the smaller the RSE is, the better it fits the data. So you want to try and minimize the RSE value. Yes, you want to minimize RSE. So let's go back over here again. And so in our case, the RSE is 11.66. So the question is, can we come up with a line that has a smaller RSE than this? And the answer is yes. And pretty much the regression line will be the line that gives you the smallest RSE. Okay, we're going to show actually the RSE for this line, for the regression line, is about 7.6. So we're going to do that in the next question 3. We'll find the regression line for this, for our men's data here, so scatter plot, and it ends up being about 7.6. So therefore the line we found up here is not the best fit line. So this line up here, the equation of the line. So this guy here. So this is the RSE for this line here. So it's not going to be, as I said, the regression line will get a smaller number here. Okay, so we're done with question 2, so let's leave the video here, and we'll do question 3 in the next video.